So let's begin. May 2017 sequences question. So what are we being told here? The straight line t touches the parabola y equals to kx squared once at point A as shown in the simulation below, where k is the coefficient of x squared. As the value k changes, the point A changes, but the gradient of t1 stays as 1. Click on the arrow to see what happens to the coordinate A as the value of k changes. So basically, this has got something to do with transformations to a certain minute extent, but this is mostly algebra. So we know that if I write x squared, so in this case I have a coefficient of 1. So in a certain case, k value can possibly be 1 as well. And if, for example, there is another case where I have written 2x squared. So what's going to essentially happen to the graph? The graph is somewhat going to become a bit narrower. If I was to write 3x squared, the graph is going to further become narrower. So what's happening as a result of it? The point A, it changes, but the gradient of T1 remains the same. So this blue line, it has a specific gradient, right? So the point that is being conveyed to us here is that the gradient of this blue line is going to perhaps remain constant. So let's continue what the questions have to say. As the value of k changes, the following coordinates for point A are recorded in the table below. If you would like to add more values in the table, click inside the relevant box, then write the values in the add label box. Alright, so that's pretty straightforward. It says describe in words a pattern for x coordinate of A. Okay, so we can see as the value of k increases by 1, the numerator of the x coordinate of A, it remains 1. However, the denominator of the x coordinate of A is increasing by 2 for each time, right? So in words, if it's asking us to describe in words, we can say as k increases, the denominator remains sorry, let's talk about the numerator first. Or even if we are supposed to talk both about the numerator and the denominator. The denominator increases by 2, whereas numerator remains constant. Alright. If it would have asked you describe an equation, a pattern for x coordinate of A, right? So you could have written this as x coordinate of A equals 2 multiplied by k. Whatever value you have of k, multiply that value by 2 and you are going to have that x coordinate of k. Does that make sense?
Yep.
Alright, great. Predict the value of x coordinate of k, x coordinate of A for k equals to 6. So that's very easy. If we look at the general rule that follows, we can say that there is an addition of 2 in each case. So here it should be 1 over 12 again. Alright, that's very easy. Predict the value. Okay, this is interesting. Write down a general rule for x coordinate of A in terms of K. So x coordinate of A was looking like this: 1 over 2, 1 over 4, 1 over 6, 1 over 8, 1 over 10, so on and so forth, right? Now we can see by default that there is something that is common, and that is a numerator of positive 1. It's common in all cases, right? So we don't have to worry about that. However, on the other hand, we should know that the value of the denominator is increasing by 2. So in terms of k, I can write this as 1 over 2 multiplied by k. We already found it in the form of an equation above, the x coordinate of a, but in reality, 1 should always be the numerator as we are referring to the entire coordinate as mentioned. Alright, so the general rule becomes 1 over 2 multiplied by k. Makes sense? Easy part?
Yeah.
That's great. Let's move forward. Verify your general rule for the x coordinate of A. So we know that the equation of the line is kx squared. Equation of the parabola, in fact. Let me write the equation of the parabola first. Kx squared. And at the same time, we have the equation of the line T1, that was the tangent to the parabola, as y equals 1x plus c. As the equation of the line is always given as y equals mx plus c, but we don't know what is the value of c, but we do know that the gradient is 1. So I can say line equals y equals x plus c, 1x plus c. Okay, so both of these things work. Since the line of T1, it touches the parabola at exactly one point. So whenever we are solving simultaneous equations, I explained this rule to you. What do simultaneous equations mean? They mean that at that particular point, the values of x's and y are equal to each other. So what do? We equate both of these y's with each other. Y equals kx squared and y equals 1x plus c. So kx squared equals 1x plus c. First of all, tell me, do you understand this part?
Yeah.
Great. Then what do we have next? I can write this in a quadratic equation form. Kx squared minus 1x minus c equals to 0. But here comes the good part. Look, remember when we were studying the equation for um, the coordinate of the x coordinate of the vertex or the turning point, I told you that the x coordinate is given as minus b over 2 times a, right? So in this equation, the value of k is a, the value of b is minus 1, and the value of c is minus c. We have got nothing to do with c. All we have got to do is with a and b. So if I want to write that this in this way, I can write it like this: x equals minus minus 1 plus 2k. Minus multiplied by minus 1 becomes positive 1, and positive 1 is divided by 2k. Is my general rule verified?
Yes.
Okay, that's great. So this concept could have also been done using coordinate geometry, but I did not do it because you haven't done it. So I did it using simple. Look, there is no new concept in it, right? This is like simultaneous, where we equate both of these equations to each other, and this is like turning point. Okay, the vertex point.
Yep.
So this is something that you have studied both. So write this down and tell me once you're done. Okay. So what they have done in this case is that they have introduced another gradient. Logically think about this. Look, both of them, both of these lines, aren't they both supposed to have the same y values? They will have the same y values, right? Because their rise or their vertical height is same. But the difference comes in their x values. A is going to have a positive x value and a positive y value. Positive x, positive y. B, on the other hand, is going to have a negative x and a positive y. What about C? Can you tell me, is C going to have a positive x value, negative x value, 0 x value, 0 y value? Can you give me an example?
Could you repeat that, please?
My question is, what do you think about the value of C? Do you think it's going to have a positive x value, negative x value, or the coordinates? What are they going to be?
I'm not so sure.
All right. Look, looking at the x-axis and looking at the y-axis, we can clearly see that this is present in the negative y-axis. This is present in the negative y-axis. So we know that the value of y is going to be negative.
All
But
right.
what about the x value? Look, if something is present on an axis, if there is a coordinate which is present on a specific axis, its opposite value is going to be 0. So the value of x here is going to be, the value of x is going to be 0. Just like when we were solving quadratic equations, x had a specific value at this place, right? Oops, let me make a parabola in a better way. x had a negative value in this way. But y didn't have a negative value. Y had a zero value. Do you recall this rule from quadratic equations?
Yeah.
Great job. Okay. Let's solve the question. We don't even know what the question is asked. As the value of k changes, the following coordinates a, b, and c have been recorded in the table below. So let's finish those values off. Um, Determine the missing values and complete the table for k equals to 3 and k equals to 4. So for k equals to 3, we are going to have, okay, these two values. So minus 1 over 2, minus 1 over 4, and x coordinate of b is going to become minus 1 over 6. This is going to become minus 1 over 8. This is going to become minus 1 over 10. Here it becomes 1 over 12, 1 over 16, 1 over 20. We did it for k equals to 5 as well, not an issue. Once again, minus 1 over 12, minus 1 over 16, and 1 over minus 1 over 20. Alright, for now at least let's just do it for 3, 4, and 5. We'll think about 6 later on. Let's see if we even need it. Describe two patterns for the y coordinate of A and two patterns for the x coordinate of B. Y coordinate of A, this pattern. First of all, we can say that it's a very recursive pattern. What does it mean? It's a term to term pattern. What do we mean by that? As the value of k, if it increases by 1, the denominator increases by 4 each time. So we can say for y coordinate of A, as k increases by 1, denominator increases by 4. Secondly, we can say that the y coordinate of A is equal to the half of x coordinate of A. So if we compare both of these terms, so have a look, or y coordinate of A is twice the x coordinate of A. Sorry, my bad. Y coordinate of A is twice. Oh, the entire y coordinate. Okay, then I was right. Then I was right. Look, 1 over 2, if it was further divided by 2, I get 1 over 4. 1 over 4, if further divided by 2, I get 1 over 8. So I can say, comparing it with the x coordinate of A, I can say that y coordinate of A specifically, not just the denominator, specifically y coordinate of A, it is equal to half of x coordinate of A. Okay, you can write these two patterns down, and then we'll move on to the y coordinate of x coordinate of B. Okay, then talking about the x coordinate of b, the first thing that we can see about it is that whenever we look at the x coordinate of b and compare it with the x coordinate of a, 1 over 2 minus 1 over 2, 1 over 4 minus 1 over 4. One good, very good answer that a student of my previous batch had answered to it was that the magnitude was same, but the direction was different. And I really like that answer, although he didn't put that in his answer key. But you see, when we study this in physics, magnitude and direction of vector quantities, we see that a value, it can be any specific value, regardless of what magnitude it has. But what really determines its worth is the sign present before it. So I can say that the x coordinate of B effectively, it has the same magnitude as the x coordinate of A, but the difference is that it is a negative reflection of it. Okay, and we can also say that as the value of k increases by 1, the denominator of the negative fraction increases by 2 each and every time. Make sense?
Yep.
Okay. Write it down and tell me once you're done. So we are told here, okay, we're supposed to write it down here, that's fine. Investigate the relationship between y coordinate of C and K. Let me take a screenshot and bring it down because this is what is going to help us save our time. So make predictions for more values of K. Uh, we're done with that. And for the example of k equals to 6, if you were to complete it, for instance, it would be minus 1 over 24, right? So you're done with this part already. Describe the part. So we have to give a very simple. We have to forget about the x coordinates and y coordinates of a and b. Just forget about it. We're doing a relationship comparison between y coordinate of c and k to be specific. All right. So in order to make predictions for more values of k, we're done with that. Describing a pattern. So looking at the pattern, we can see that the y coordinate of c is, first of all, it's negative. Secondly, as the value of k increases, the denominator of the y coordinate of c increases by 4 as well for each unit. We can say as k increases, denominator of y coordinate of c increases by 4 for each. There's no need to give more detail, that's fine. Then looking at this, we have to we have described the pattern, we have made prediction, we have to find a general rule. Okay, the general rule for the y coordinate of c in terms of k. Once again, our numerator is similar. So first of all, in the numerator, let me just write down as minus 1. In terms of k, I know that the value initially provided when k was 1, it was 4. So when k was 2, it was 8. So essentially what's happening? there is an increase of 4 with every value, right? But if it says, if it has said that it should be in relation to k, it means that I should write it down in a multiplication form. So I will write this as an answer minus 1 over 4k. And we could have seen that when the value of k was 1, the rule was simply 1 over 4 times 1, which is 4. And when k was 1, we had the y coordinate of c in the form of 1 over 4. And this is what is done for testing our general rule. When k equals to 2, this is the rule, this is testing. When k equals to 2, we had, sorry, minus 1 as it is, minus 1 over 4 times 2, which is minus 1 over 8, right? And we had that answer, minus 1 over 4, minus 1 over 8. So write this down. Write this rule down so that we can move forward. Now, prove or verify and justify your general rule. Verification can be done with the values that we found, which were not initially given. So for the values of, for example, 1 over, minus 1 over 16 and minus 1 over 20. So that's also pretty easy. That's not much of rocket science. Let me just verify this rule. Minus 1 over 4 times 5, this becomes minus 1 over 20. So when the value of k equals to 5, the y coordinate of c is going to be minus 1 over 20, and we can see that from above. How to justify this part? How to justify? Look, I want you to just focus on it now. We can see that this point C is a y-intercept of this blue line. Okay, so when I told you, when I wrote the equation of the line, I wrote it like this: y equals positive 1x plus c. We knew that the gradient was given to us as positive 1, and of course this green gradient was given to us as negative 1. This has been told to us here. Okay, they told us this. But what about the value of c? We don't know that value, right? So I can write the coordinates as 0 comma minus y, or simply 0 comma y coordinate of c, whatever that value is. And at the same time, I know that this is tangent to this parabola, and that parabola has an equation y equals to kx squared, and this line has the equation y equals x plus c. Okay, whatever the value is. If I was to equate both of these two y's once again, all right, so I would get kx squared equals x plus c, and kx squared minus x minus c, where c represents the y coordinate of c basically. So let me just write a small y to make you understand. Otherwise, if you don't do it in your exam, that's fine. But just try to understand this for now. This equals to 0. Okay. what do we know? I know that this point, it touches the y-axis at only how many regions? In only one region. So when I was teaching you quadratic equations, I told you one thing. The quadratic equation said minus b plus minus under root b square minus 4ac upon 2a, right? So minus b over 2a determines the value of the turning point, but b square minus 4ac determines where the values of x are essentially present, positive or negative. All right. So b square minus 4ac, do you remember this when I taught you in class? Although this is not inherently a subject of the IB/MYP syllabus, but I still taught you because I knew this is something going to help you in sequences, right? So I told you all that b square minus 4ac is the value that determines the real coordinates of the intersection between the x-axis or the parabola, or the x-axis and a line, or a parabola and an x-axis. It totally depends on the situation. So I can say that the value of a can be written as k, the value of b can be written as -1, and the value of c can be written as simply 1 as well, because we haven't been assigned a value. Let me substitute this value. So I got -1 whole square minus 4 multiplied by a. A is k and c is 1 again. This is equal to 0. -1 whole square is 1, and let me in fact just write c as c. Okay, 1 minus 4 k c. 1 equals 4 k c, and the y coordinate of c is 1 over 4 k. So isn't this the exact answer?